You might ask the question, why does the title of this presentation contain two images? One is an image from the 1976 landing of Viking, one of the first pictures we took of the landscape of where Lander 1, Viking Lander 1, took place, and a picture of Tim Much to his left, excuse me, to his right as you're looking at the picture, is Carl Sagan. And that represents a concept that I want to talk about that took place on Viking that relates to the PI function. If you could imagine that Viking, instead of being a Battleship Galactica type of mission, it was a program. And in a program called Viking, as the planetary program might be called, one element of it was to image, from a geology viewpoint, the surface of Mars. And Jim Martin, in the 1968 time period, came up with the idea that he would use the AO process in its old format to select a group of PIs for each of the instruments. And Tim Much, who was a university professor at Brown, very much interested in exploration, but geology, but had never been involved in a NASA mission before. He gets selected as the AO, and he talks about, in this book, called The Martian Landscape, and I recommend it to everybody to put this on your tabletop if you can afford to buy it. It is a NASA publication. It not only has all the landed pictures from Viking, but has a story in there of the life of a PI going through 8 years of development. And by the way, I have to admit something very honestly. I worked on Viking for 8 years. I'm going to give you a presentation on how we worked hard to control cost on it. But I was sitting in Brad Perry's office waiting for him for a meeting, and I found this book that I didn't know was ever published. I'm embarrassed to tell you that. And I started reading it while I was waiting for Brad, and I said, my God, if Tim was alive and with us, he could tell a much better story about how, as a PI, he lived to do the Viking landed imaging project. And I commend you to this. If you see me after, you could pick up the label for it. Maybe someday we'll get Ed interested in giving you a copy of it. But Ed, are you back there? And even though it looks like a tabletop book of pictures of the Viking lander on the surface of Mars, it has a wonderful first-class story of the life of the PI over 8 years in development. Okay, let me talk about the Viking project. There was no question that the video I mentioned of Tom Young, the message we all got as being principals on that project was that we were science-driven. We were not going to carry out an engineering feat. We did that from the first day by putting a very strong science team together, and they worked from the embryonic stage of the project in 1968 to the landing, to the post-landing, to the publication period. And I already mentioned the Tim Much story that I wanted to use. And my statement that's bold is that he was probably the first PI within a large science mission, meaning that if you use today's PI-led project, he was delegated by Jim Martin to lead the function with engineering help from Martin Marietta engineers and NASA Langley engineers to carry out the aspects of designing, developing, and delivering the stereo image. You know, you were talking about redundancy. One of the decisions that Tim made very early was, why don't we get redundancy by putting up 2 cameras, and then we could get the benefit of stereoscopic event. And so that allowed him to produce in his book a stereo optic thing, so you can look at the images in stereo. And but the more important thing, it was backed up as to you have 2 operating cameras and you get redundancy in design. That wasn't a principle that we carried out when the AO went out. It's what Tim contributed to the program in terms of, let's add that as a benefit. We get a stereoscopic view of the landscape, but on top of that, we get redundancy if one camera fails. And I thought it was a kind of a unique technique, and shows how scientists could drive the design in a very simple way, because you develop one camera and you use it stereoscopically. He participated in every Viking decision during development, test, and mission operations. And I thought that was key. He not only reported up to what I would call the Viking program, if you allow me to use that thing, but he managed down within it. And he had a Martin Marietta and a Lockheed, excuse me, I'm going back to my own background, and a Langley engineer that acted as program managers within the camera development. I already mentioned he was significantly involved, but he was also a member of the land of science team. Geology was only one of the principles. In fact, it was a biology-driven life detection mission, and he had to get involved in one of the decision processes I'll talk about that John Newcomb was very much involved in. Is we were supposed to land on July 4th, 1976. There was a significant date attached to that. It was not only the bicentennial, but they were going to open the Air and Space Museum and send a signal back from the Viking orbiter at the time to open up, to cut the tape to open up the Air and Space Museum that we all know on the Mall in Washington. Well, when the orbiter got finished its reconnaissance mission, the landing site we had selected was high risk from an engineering viewpoint. And from July 4th, to July 20th, John, 16 days of hell took place with the science team leading a very important function to pick an alternate site in real time from the orbiter data that was available. And the picture I showed you was that meeting that took place where Tim just finished telling Carl Sagan to shut up because he was talking too much. But it was an interesting play. And by the way, let me mention, Carl was a member of Tim Much's science team. And so was Alan Binder, who became a member of the Lunar Prospector PI in the first Discovery mission. And Jim Head, who was now at Brown University, involved in the MER program and other things. So the legacy goes on. And we mentioned Orbital Sciences, one of the principal people that was a co-op at the time, is the current president and owner of Orbital Sciences. So, you know, the beat goes on. He attended, he tells you in his book, little did he know when he agreed to bid this job, he attended 400 meetings in 8 years to show you his involvement and how it changed his life. He went on to become the AA for space science, replacing Noel Hinners later, and he got touched by the whole management function and leading science rather than doing science, and it was an interesting aspect. He said travel became a routine way of his life, is that instead of commuting from his house near the campus of Brown University to work every day, he found himself going to the airport and attending a meeting somewhere, and he wants to share that with you if he was here today, that you have to make that kind of commitment. And I think Ken would tell you, and John, who participated in the flight operations, that it was the prime example of a badgeless society. Jim Martin, as the project manager, put a team of scientists, engineers, systems engineers, everybody. They stayed from launch to the 9 or 10 months of transfer from Earth to Mars. During all the data collection, they worked as a team in one building, and that building still exists at JPL and is the mission center for future missions. What I try to do now to try to get generic from Viking is talk about what are some of the features that help control cost. And if I was to think about the things we did very early in the program, Langley had the leadership of this mission, but we had full respect for JPL's capability. They were going to do the mission operations control. We were going to use the Deep Space Network, and part of the design, instead of the earlier mission on Fuse, where we talked about, we used a spacecraft from another program, and Lunar Prospector did the same thing. We went to the orbiters of the 4 successful spacecraft launched on Viking. 2 of them came from JPL heritage of the earlier missions on Mars that took place. So the Mars orbiters were JPL provided, JPL managed, and delivered to the program. And so we were teamed with JPL. Assigned performance accountability, held team offsite meeting. In 1968, within 6 months of getting the project approved and moving out, Jim Martin brought everybody together and had everybody talks about what he thought their roles and missions were, what their accountability was in the program, and we made real-time adjustments in that room right off the bat instead of everybody assuming what their roles and responsibilities were. And I strongly carry that in my leadership lectures, that that's a very important thing to do. Don't wait for cancer to form. Nip it in the bud and bring it in right away. Effective communications. We were the first project to use advanced data systems. Remember, this is 1968 to 70. We started one of the first activities to communicate and approve documents through an automatic data system. A short story I'll tell you about that will stay in my mind for the rest of my life, which probably isn't too much longer, but it was very, very effective. I was managing, for Jim Martin, all the cost on the program. I was what was called at that time the deputy for management in the program. And Martin Marietta was spending all kinds of money, and I told Jim, I said, we're losing our focus. We're there to get landed data from Mars, and instead we're developing an advanced communication system that could be used for life, and it's going to be great, but we're spending money for the wrong things. We should be concentrating on the science and the hardware development and everything else. And he said, okay, Gus, I'll listen to you. So he said, there'll be a committee formed. I'm the chair. Tom Young will come and you, and we're going to go to Martin Marietta and get a full story, and then we're going to make a decision on whether we continue it or not. And we go to this meeting in a typical Jim Martin fashion, and the presentations are made, and he says, well, Gus, what do you think? I said, I think we should stop it and put our money against the mission. And he said, Tom Young, what do you think? He said, well, Jim, he said, well, Tom, before you say anything, let me interrupt you and say that, are you also against progress like Gus? And Tom says, no, Jim, I was just about to say, Jim, that I think we should continue putting money in this because it's the greatest thing. So we continued it, and by the way, he was right. He was absolutely right, because we started to develop techniques that save travel money, save activity. It looked like a costly thing to start. That's the message I want to leave you. But there are long-term implications that save money in terms of what we've done. And that's the message I want to give you. Controlling the project. We had Monday technical. We never had a business, an organizational staff meeting in 8 years on Viking. All our meetings were intended to control the project. And the emphasis was on, it was Black Monday every week, because you were only allowed to talk in the meeting if you had a problem. Because we were problem oriented and problem solved. And he invited everybody that controlled resources to be in on the meeting. Now, we didn't have teleconferencing, we didn't have video, we did it by charts on the wall. And if let's use my own personal experience, one of the short stints I had in Viking, I managed the GCMS program, the gas chromatograph mass spectrometer. And Jim had a habit of taking people and putting them where the action was needed. And I was on that list of problems almost every week in terms of talking about it. But within minutes, I was having a electronic problem in one of the boxes, and there was corona being caused by it. And Jim says, "Have you know where it's coming from?" I said, "Yes. We decided to have inspectability in all our potting on our electronics, and as you know, and if you go to Mars and its atmosphere, if you operate on the Paschon curve, if you get a path with the pressurization system, you can get an arc, and we were burning out the filament in the mass spectrometer." as part of the GCMS. And sitting in the room was Ed Courtwright, who was the center director at Langley, and he raised his hand. He said, "Gus, I could solve your problem." And Jim says, "Okay, Ed, I want you and Gus to go out to Hughes Aircraft had the solution for the problem, although they weren't building the instrument. Linton was building the instrument." And he said, "Go out there and solve the problem." I mean, that's the kind of characteristic. If you didn't develop an activity that said, we're going to talk about our problems rather than our solutions, you would let grass grow and the thing would get on, and you would get into these stories of, yeah, we got a problem, but I think we got a solution for it. Jim was of the type that said, where's the problem? How could we solve it? Get out there and get it fixed. And the fix was in a classified area that I wasn't cleared in and Ed was cleared in, so Ed turned out to be the systems engineer to solve the problem. And it's just a type of technique that I don't say everybody should get their center director involved, but I'm saying don't have your meetings concentrate on trivia and what's good. Have it concentrate on where the problems are and where you can put your resources best. Develop alternate plans. We had a list of 150 cost offset items. Now, it was a very large program, and we didn't dream of money we were going to save in the operational phase. We talked about what we could do next week to still meet the mission success criteria, but change the way we were approaching solving that problem and fix the problem that was at hand. And when that list was attacked, it was developed by the engineering people with good cost figures, and when we decided to implement, we then gave them 1 week to come back and said, what's the fallout of that decision in terms of what other collateral activities could take place, and they came back and we either did it or didn't do it, and it was our way of staying within the cost box by being very, very diligent about exercising. And when the term on the 150 would get changed each week, we only have 135 less because time pushed out where we can't get that saving or we can't get that activity, and it became a very good thing. Also, this is the hardest one. You've heard this. It's a trite expression, is the golden rule. Insist on holding all the reserves. Jim was successful in negotiating with the headquarters at that time the fact that he would control the allowance for program adjustment instead of just the normal reserves. Now, he had a responsibility to report to, and I can't remember, this is John Noggle before Noel Hinters, that we reported everything we were going to do if we were attacking the allowance for program adjustment. But Jim definitely believed that if you have the goal, you could rule. And that was his, this is an EN Golden, not an IN Golden. So, ethics and trust. We had a big family and a big team. There was maybe at peak 5,000 or 6,000 people working on Viking. And Jim Martin set the tone of the way you act, other people will act. The way you treat people, the way you resonate with them, what you do on travel, what you do in your life, or what you do after work, was a very important thing, that you treat it like you're a first family, and you got to be Caesar's wife. You got to be above reproach in terms of everything you do. So he carried out an image of we're a first-class operation, and that's the way we're going to operate. And now, how does that control money? It controls it because people have sensitivity of hell. When we traveled on Viking, we would double up in a Motel 6 for $8 just to save money on travel. And all of that had to do with, you don't live the high life, and you be sensitive that you're spending the government money. We were probably the first ones that carried Jim Martin came to NASA and then to the Viking leadership through a commercial activity. So he had a very significant viewpoint of who the customer is. And he drilled into the scientists that you might think you're our customer in terms that we got to deliver science, but it's the American public, it's the United States of America, It's the loyalty of NASA that we're delivering a product. In this case, it's science. And you have to participate in that viewpoint. So we would carry out the aspect that creating customer value is understanding who the customer is. And it might be, in your mind, the Congress of the United States, or it might be the citizens of the United States, but it's broader than each other, is his message. The lessons learned that we brought into Viking, believe it or not, came from Lunar Orbiter, as well as what Jim introduced from his own set of experiences. Here's another set of things. Organize to win. Get clear understanding of the science objectives. Remember the past, assess the present, and apply first-class methods of systems engineering. You keep hearing this word systems engineering over and over again. It is classic. There's no question that Viking would have not been successful without an Iz Tabak and without a Gentry Lee on the Martin Marietta side, carrying out the cross things that take place within a project beyond whether it's a landing imaging system or otherwise. Develop a strong bond with other centers and contractors. It was a classic example of a badgeless society, that there was no, everybody was on the Viking team, not on the Martin Marietta team or the iTech team who developed the camera or the science team. They were all there together to accomplish the mission, and he developed that strong bond when he gave responsibility to what is now the Glenn Research Center or Lewis Research Center to develop the Centaur portion of the Titan Centaur. Andy Stofan was his manager for that, and Andy thought he was a member of the Viking team, not a member of the Lewis Research Center, and it became very important. 2 minutes? Okay. My charts will be available to you because I'm taking too much time for this front end story. I'm going to close out with my lessons learned, which are the last two charts. And this will be copied to you, that it just goes into more detail of all the others. Okay, this is, if you get a chance to not only look at my Viking experience, but look at my total integrated experience, I sat down and wrote some lessons learned from my career that I'll share with you, and you just think about them and see what you think. And they turn out to be points and counterpoints in each case. Never lose your capacity for enthusiasm. If you don't enjoy what you're doing, go do something else, because you got to wake up in the morning and feel good about going to work, as tough as it might be. But you're not the cheerleader. Remember, when you just can't be enthusiastic and make this happen. So my counterpoint is never lose your capacity for indignation. If you're unhappy with something, if something's not going right, be able to express that. Never judge or classify people too quickly. First assume that she or he is good. Think positive about the thing. Never be impressed with wealth or thrown by poverty. And the classic example for that, when I was director of planetary programs, I was in charge of the R&A budget, which many of you in the room are familiar with. And one of my researches on post-Viking, post-Voyager, all the data that was collected during the time period I was there, which was 79 to 81. Carl Sagan was one of the benefactors of the R&A program. But he was also doing the Cosmos series at the same time, which was very important to the country in educating them about science. But he wasn't carrying out the money I was giving for to support his graduate students and support the post-data analysis phase. And I had the ability to call him up and tell him his contract was being suspended for non-delivery. And the same week I was doing that, his picture was on the cover of Time magazine. And that's what I mean by not being impressed by wealth. If you got a fiduciary responsibility, you got to carry it out, and carry it out with vigor. Carl never did lose his contract, and he started to get his reports in, and he started managing his graduate students. And thank God for that, because one of them is the PI on the MER program. If you can't be generous when it's hard to be, you will not when it's easy. as tough as life was on Viking for 8 years, I still managed to support my 3 sons in Little League and support the church and do a number of things. And if you can't do it when you're busy and pressured like that, you'll never do it when you're in the leisure state of my life right now in terms of being able to contribute. The greatest builder of confidence is the ability to do something, almost anything well. When I had a bad day at work, I'd go home and change the oil in the car, or tell my wife I'm going to wallpaper the bathroom. I had to do something physical that made me look at it and get an instant report back that I'm doing well. So when you have those bad days, find something to do that you could reward yourself, where you do a personal assessment and feel good about it. And then when that confidence comes, then strive for humility, because you're not that good after all. And the way to become truly useful is to seek the best of other brains and have to offer, and use them to supplement your own, and be prepared to give them credit. Make sure that you do that, because you owe it to them. And if you use them, don't abuse them. The greatest tragedies in work and personal events stem from misunderstanding. And ladies and gentlemen, my answer is communicate. That solves most of the problem. Be truthful. Thank you very much.
Subtitle this talk of how the Cassini payload reserves were managed, to be more specific. We had a series of difficult problems to solve, and we evolved an approach which worked very well for us. And what I'll be doing is describing that. I guess relevant to Viking, this is a smaller project. We only had 2 spacecraft, the orbiter here and the Huygens atmospheric probe. This antenna is 4 meters across. This is 4 meters diameter here. 5.5 tons loaded when it was launched. What you see here are the flags of the countries that were involved in building the hardware, which is now at Saturn. The challenge on the payload is we want to deliver all the instruments, have them delivered on time. Hardware items were responsibility of PIs, and in several cases, responsibility of the project. It had to be within cost, at allocated mass or less, at allocated power or less, allocated data rate, and within an agreed upon configuration. You couldn't put a huge mass out on the end of the magnetometer boom, for example. So configuration was also important. We also had desirements. We wanted to have an optimum use of payload resources, meaning in particular whatever reserve or margin we had to spend on the payload. We wanted to have the best expertise involved in any reallocation of these payload resources. And of course, we'd like to have a minimum of management overhead, which is, there's some ways you can do that. I'll get into that in a moment. The situation was as follows. We had 26 investigations, 18 instruments, a dozen of them on the orbiter, 6 on the Huygens atmospheric probe. And most of these things involved cutting edge technology of some sort or other. And from one instrument to the other, the technologies were all different. So the problem is you have a problem getting expert advice for how to use your reserves, because the people on the instruments, I mean, they have a vested interest, you know, give it to me. And so it's an expertise problem. In about half a dozen cases, all of the world's experts were associated with payload instruments. So you're stuck with a problem of conflict of interest or making a judgment out of ignorance or in ignorance. We needed a process for using the expertise that we had on the project already, which was conflicted, and avoid that conflict of interest. The answer to that was, and to some other problems, was to set up a free market trading system so the people responsible for building the hardware could exchange dollars, mass, power, data rate, and so forth with each other. Now, that's easier said than done. You have to start off from a point of reference, and so on the payload, we negotiated delivery contracts with each PI, and I will use PI as a stand-in for whoever is responsible for delivering that hardware for the 18 instruments. And we held expert reviews, so you see I'm using expert in quotation marks here, to verify both to the PI and to ourselves that for the resources being requested here, they in fact could deliver. Then after that was agreed upon and the contracts signed, we distributed all the payload margin to the PIs. That was about 15% in most of the categories. So now each instrument not only had what was agreed upon they could deliver the instrument for, they then had the additional reserve given to them to use as needed. And I mentioned these quantities here already. So we had to provide a method for the PIs to trade these resources. And that was what the resource exchange was. You have to define the method very well. You have to have established rules. I mean, you don't want speculation. You want people to be serious about what they're doing. And when we got this going, and my counterpart in Europe, in ESA, heard about it, he says on the phone, I understand that you have become the casino project. And so perceptions were something which had to be recognized and addressed. But once we had gone through this whole process, we opened the market, and the group at Caltech was also using this as a research exercise. Set up an electronic market so PI could look and see offers and requests and stuff displayed electronically. The project manager, myself, and the payload manager had veto authority because we were a little bit worried what was going to go on here. Someone might figure out how to game the system. Well, fortunately, that didn't happen. Neither the project manager nor myself ever had to exercise a veto. The payload manager had one that he exercised on the basis of a problem with configuration. Too much change in the spacecraft center of gravity and so forth. But then that got worked out, and a modification of that trade went through. Most of the trading turned out to be in money, phasing dollars from one fiscal year to the next. And very quickly, a discount rate of 6% emerged. There wasn't any requirement for that. But if I have money that I know I'm not going to use, I can loan it to you, and then next year you pay me back that plus 6% if it's for a full year. Now this was, once this was agreed upon, then the payload manager just adjusted the budgets accordingly, and that was the end of it. It was a done deal. Okay, the contract was, if you deliver your instrument on time and within your resource envelope, you will fly. If you have a problem with your resources and you can't get the resources you need, then you're going to have to descope. That's your responsibility too. We're not going to tell you how to do it. So I can go on with stories and discussion for a long time here. What I'm going to do as a device to focus attention is address these topics here. Margin vesting, who changes the resource profile? What about the visibility of resource usage? How do you optimize the margins? Who's going to fly? You've got some idea about that already. something about trading complexity, and then overhead, team building, and then the lessons learned. So getting right into that, margin here, or the reserve, was vested in the PIs. It was theirs, they owned it, that was that. In the traditional method here, and a lot of this discussion I've had with Bill Fawcett, who was the Cassini payload manager. Typically, in many projects, the payload manager has a reserve account, and then he trades in and out of that account as needed. Here the PI is vested, it gives the PI control over his fate. Who changes the resource profiles? Well, traditionally, it's the payload manager, maybe with the approval of higher management, but the problems here is that manager does not have detailed knowledge of the situation and doesn't have the necessary expertise. So the additional problem is every margin allocation out of his account is a win-lose transaction. If you get the margin from him, you win. Everyone else loses because available margin goes down. And should they need it later, it may not be there. This leads to the early bird gets the worm syndrome. I'm bankrupt, help me now. You know, and if you get in there and do that first and make your case, you get the reserve. Some person who works very hard to make do with what they have and in the end is short just a little bit, the reserves may be fully allocated then. I'm sorry, you lose. Or you have someone that says, look, the NASA board said, my instrument is more important, take it from someone else. In the exchange here, the instrument PIs make all the decisions. They are the ones best qualified to evaluate the complexity, risk, and the needs of their instruments. They also have all the expertise on their team. So that's good and bad. I had one person tell me, darn it, he said, in our team meeting we had this last week, we spent a whole day just talking about one trade offer we were going to make. We're analyzing risk, analyzing that. So this takes a lot of time. Yeah, but you got the right people doing an analysis and making the decision. Visibility of resource usage. The payload manager is often expected to maintain a predefined reserve profile. You get at certain stages of the project, if he doesn't have that, then he's under pressure to increase his reserve if it's too low for that stage of the project. So he's got to form a press gang and go out and beat up on the PIs and squeeze those resources out and put them in his account. So as a PI, if you got some mass that you're pretty sure you're not going to need, you're wise to hide that fact. Or if you're going to not spend all your money this fiscal year, you better hide that information too, because otherwise you get money taken away from you. In the exchange environment here, there's no advantage to secrecy. There's no required reserve levels. That was the problem for the PI for each instrument. Knowledge of reserve is continuously available. The openness of the information has some advantages. Sometimes people make helpful suggestions. A rich instrument can make a gift to an instrument that's in trouble, particularly if they have some collaboration in mind in the future where they would want some data from the instrument in trouble. They can make side deals or arrangements. Also, it promotes shared developments, such as data reduction hardware, and software, I mean, things like that. This was particularly true among the fields and particles instruments. They collaborated on a large data system for science analysis, both in this country and in Europe. And as a result, they all contributed some to that, and there was something that benefited all of them. What about margin optimization? Depends on the skill, or some say luck, of the manager. He needs advice from external experts. And the PIs are trying to hide everything they think they might not use, but don't want to give it up just in case. System tends to drive the outcome in the resources exchange in the direction of optimum usage. Very strong motivators. I mean, as you get down toward launch, the value of mass and power is continuously declining. Time you launch, mass and power have value of exactly 0. So once you're really sure you're not going to need some power or mass, your best strategy is to get some money for it. And if you have enough money, you can always enlarge your investigation in some way. So strong motivation, and we talked some about loans to get interest. Who will fly? We've had a lot of discussion or mentioning of that in this forum earlier. Management decides. When management feels it must raise more reserve and it can't do it, it removes an instrument. Here, the flight is guaranteed if they deliver on schedule. It's a big morale booster because every trade is a win-win transaction. And if you're trying to build morale, having a series and a history of win-win interactions is very important. In the payload, a lot of the complexity that's possible depends on the skill of the payload manager. And Bill Fawcett, who was certainly a master at this sort of thing, said, boy, I'm glad I don't have to do this. I'm glad I don't have to form press gangs and so forth. But we have single transactions. Payload manager moves the resources in and out of his account. And transactions are against the current holding in the payload reserve account. Over here, we can have 3- and 4-party transactions. Parties do not necessarily need to trade with each other. But once you get beyond a 2 exchange with 2 parties trading with each other, it gets complicated. And we had one of the Caltech people served as a broker, and we also had software to help look for multi-party exchanges. And we had fewer than half a dozen multi-party type exchanges. It wasn't a big deal. The big deal was phasing money between fiscal year. Overhead. Payload manager must prepare for each decision. I mean, who wouldn't? The guy's smart. He knows these are complicated decisions. But then the unhappy parties, as a result of the decision, may appeal. Go to the project scientist or project manager, and so on. You know the old story. But all parties have to prepare for each level of management shootout. That's a tremendous amount of activity you expend on that. Here, decisions are made at the lowest level. They're basically made by the PIs. Trades are final. There's no appeal. PIs are not compelled to trade. They only trade when they feel that they will benefit from the transaction. I mentioned this before. In the management payload manager approach, we have winners and losers all the time. In the resources exchange, the transactions are win-win. My conjecture is everybody's happy. It may not be true, but I mean, everyone's doing win-win, and so you expect them to be happy. But it's strong team building that results from this, which I think we get into our lessons learned, because that's what this transitions into. The traded commodities and rules must be well defined, that any uncertainty kills the system. Our science manager was worried that there wouldn't be enough power available as a result of this for pointing the spacecraft when we had to go from one position to another. So over there, there was a little cache of power, okay, and it got discovered. And so the PI said, why should I buy power? Because when we launch, that cache is going to become liquid, and I will get whatever I need. So there were no transactions on the power market. But mass, there was a lot of transaction, and it got very complicated because the instruments as a whole, it turned out, needed mass. They were all running short. But it turned out the spacecraft, as the fiscal year was closing, was running out of money. They're going to have to shut down and turn off the lights. And so we had a side auction where the spacecraft had a lot of mass because they had finally adjusted all their assessments, and some of the hardware had been delivered. They knew what it weighed. So they auctioned mass. PIs bought it, and everyone got through with a win-win transaction. You can imagine that the payload manager had gotten the job of going around the instruments and squeezing money out of each one of them. Team building through win-win, I've talked about. Resource trading worked well for us. All 18 instruments flew to Saturn. But you very critically dependent on it being a well-defined system with the commodities that are being exchanged being well-defined. Here's a reference if you want to dig into this some for additional reading. And certainly indebted to guys like John Cassani, Bill Fawcett, John Ledgert at Caltech, Dave Porter, Randy Wesson at JPL for being involved in helping getting this thing formulated and run. Thank
you. Before I get going, what I did is I took the theme of allocating margins and how you and decided what would potentially be of value for the New Frontiers missions is understanding once you have your margins to get yourself to the finish line with some sense of order and staying within the box, since that's the theme, right? And, the PI-led missions, especially the exploration missions, you've got a fixed launch window. So the paradigm is somewhat different than a project like FUSE, where you're in an Earth orbit. So typically with an exploration mission, if you miss the launch window, you're done, because you're not going to get funded for another 13 months, or in the case of Mars, 26 months. So you're constrained with your schedule. You're cost capped, right? If you blow through the cost cap, they're going to pull the plug on you. And you've signed up to level 1 requirements, and you do have some flexibility there. But the whole reason to fly the mission is to go get the science. So you don't want to start descoping, because that means you failed to adequately manage your margins. So what I have here is about a half a dozen things looking back on Phoenix that I would consider applicable lesson learned for PI-led missions, and they proved to work pretty well for us on Phoenix. All right, before I get going on those, I'll kind of set the framework a little bit and provide the PIs and the project managers and the mission systems engineers a little context for there's things that can happen that are way out of your control. All right, Phoenix was the first of the Scout missions. It was the competition for Scout 1 took place in calendar year 2003, and the announcement on the winner of the first Mars Scout mission happened about August 1st of 2003. All right, so we put a proposal together that was probably the underdog. Ed Weiler had said previously that that lander is never going to fly. It had black marks against it because it was a sibling spacecraft from the ill-fated Mars Polar Lander. Yet the underdog came out on top. And so there's certainly a lesson there for all of the current New Frontiers missions. You may not feel like you're the front runner, or you may not recognize that there is or is not a front runner, but anybody can come out on top. It all depends how you handle yourself between now and that site visit. What happened to Phoenix was it was awarded the Scout mission, and then NASA went, oh my gosh, the lander won. Now what do we do? And the reason that was an issue is MSL was in the wings. All right, now all of a sudden the #1 risk on the MSL risk list was failure of the Phoenix lander. because that could throw the entire Mars program into disarray. So you've got this scout mission that was put together on tenet of being a focused, lower cost scientific investigation of Mars, and all of a sudden the rules changed. The paradigm that we were operating in of being cost constrained, schedule constrained, and focused science, that risk paradigm shifted dramatically. Our environment that we're operating in further changed when MER landed. Even though the landing systems were very different, the atmospheric entry, hypersonic, parachute phases, there was data that was acquired by the MER landing systems that was unexpected. Right? And as a consequence, the Phoenix mission, needed to factor in two major outside influences that were not within the realm of the baseline that we proposed. One was the risk paradigm changed, and two, that we had data from current missions that changed our risk posture. All right, now MAVEN, as Martin well knows, is in Phase B, and it's currently contending with strong heritage to MRO, and there's been some in-flight discoveries with the MRO behavior. Now MRO is real solid, it's working really well, but when you have to be able to react to in-flight evolution of and discoveries on those concurrent programs. Every one of the New Frontiers missions and MAVEN have strong heritage. And so that's the last point I'm going to make before I get going on this is understanding your heritage is really the basis for how you can establish your margins with credibility. Right now, all three New Frontiers missions think they know their margins. The reality is you don't know your margins as well as you think you do. And the heritage of the systems that you're going to fly, that you're going to propose, the hardware and the software and the operations concepts that you have, all those things really need to be well understood. And you need to understand the application of your heritage. The fact that you're going to reuse code is great, but how is your mission different? It's clearly not the same mission because what everybody's being asked to do is different than what's been done before, or you wouldn't have made it to this point in the game. All right, so understanding what is unique about your mission, where your challenges are. I mean, what is that magic widget that you have to design, or that critical event that you're going to engage in that hasn't been done before? That's really where the focus, we're having focus on that benefits the team, and where you really need to understand your margins and making the case for having that understanding of margins, how you're applying your heritage. And you know what that all boils down to? It's systems engineering. Right? So you've got to understand what you're doing, the decomposition of your requirements, and how the heritage that you're going to claim is really going to be applied, and how the margins that previously existed with that heritage, how that margin complement has changed for your mission. Just because you're going to fly a RAD 750 processor that had throughput margin of 40% at peak loading on MRO doesn't mean you're going to have the same thing on your mission. You may find out that you need to make substantial changes because of the margins that you're going to find. Okay, so I'll get going on the lessons learned now. There's about 5 things here that some may sound obvious, and you're going to see a lot of commonality to what the earlier speakers were talking about. Managing critical path. Well, okay, obviously, you need to do that. If you put the right amount of margin into your critical path and put it at the right points in your flow, you give yourself a leg up. All right, everybody knows that they need to have critical path margin for the assembly test and launch operations, but every subsystem needs to understand their critical path and their secondary critical path. And then the project leadership, it's of utmost importance that you don't allow that critical path to erode before you need it. As an example, avionics boxes. It's the parts engineering, the screening of the parts, there's things that come out of the woodwork that you can't control. Micro semi diodes right now in the industry is just a mess. And you know, you're going to get these guide up alerts that come in, you're going to get lot failures, and the importance of keeping every one of those components on track before you start out low is really important. It's not at all fun to be talking to your box lead for your power distribution box or your flight computer or one of the comm boxes and tell them that, you know, I can't let you use that margin right now. You have to hold your schedule, and I'm going to give you the reserve that you need to go get that done. So it's really important that the team understands that when they have a problem, that you have the resources to help them solve their problem. Usually you don't give them what they ask for. You give them enough to help them over their problem, and then if the problem continues to get more difficult, then they get more resources. But I guess one of my lessons that I learned going through Phoenix was you very rarely give somebody what they're asking for, but you always give them what they need. And in the end, it turns out that what they needed was probably a lot less than what they asked for. All right, so trying to figure out how to turn that dial is, I mean, there's a lot that goes into that. It's calibrating that person when they tell you that the sky is falling. Is it just a portion of the sky, or is it the whole sky? All right. Okay. So the reserve is there, but it's only, the schedule reserve is really only for those tough problems. It isn't for the things where, you know, I like to get home for dinner too, but it doesn't always work that way. All right, so sometimes you just have to ask people to suck it up and not allow that schedule to get eroded early in the game, because you know you're going to need it late. All right. This message down here is one of the most important ones that you can lose sight of. You've got a set of requirements you signed up to, you've flowed your requirements down, you've got margin against those requirements. That margin against requirements is another form of management reserve. You've got schedule, you've got mass, you've got power, but you also have excess capability. And if you allow your well-meaning team to give you changes that improve the product, get you more performance, what you're doing is you're eroding your reserve in the form of that excess capability. It's far easier to get to a 90% solution than it is a 95% solution. Right? And if you let that capability get withered away on you, you're going to be fighting lots of fires that you didn't need to fight. So that's something where between the project leadership at the NASA Center and the leadership of the contractor and the PI, you all need to be on the same page with this, where you're making sure that capability still exists above requirements. There's going to be a day when you're going to find out that you're not getting the result from your attitude control algorithm convergence, or the propulsion system is going to tell you that, well, they've got some alignment issues that they hadn't anticipated with thrust vectors. You never know where it's going to come from, right? And then the bottom line message is your problems aren't like wine. I mean, it's not to your advantage to let them sit and age and get better, because they're not going to get better. It's going to be more like something rotten in the garage, and then you're going to have a big mess on your hands later. So get on them, kill them early. The ability to solve a problem and kick your team in a little bit different direction, it's far less input that you need to change the direction when it's a small angle. If you wait till late in the game, and you got to dump tons of resources in because you have to make a big change in a short period of time. Okay, risk management. I said this yesterday, that my belief is that the sooner you recognize that the path to launch is fundamentally an exercise in risk management, the better off you're going to be. The way I view this is the leadership of the project, you all are moving chess pieces around on a board, right? And you need to be 2 and 3 and 4 steps ahead of the rest of the team. If you're not, then you're going to be playing catch up to the team. You're going to be surprised by the developments, and you're not going to have contingencies laid in. All right, so you need to be communicating. The PI, the project manager, the contractor lead, the instrument leads, you need to know where each other's going, where you're likely to have issues popping up, and you need to have thought through the contingencies for how you're going to work through that. And you're managing risk, not only the technical risk, but what's the schedule risk sitting out there, and how are you going to work together to help keep everything moving without allowing the risks to blow up on you. All right, so the making the whole leadership team accountable is really important. Once the subsystem leads realize that they need to identify risks, they need to give you visibility to them so you can help them and be an advocate for helping everybody solve their problems, then the team is far more willing to tell you what their issues are. You don't want to get caught into the shoot the messenger syndrome. The weekly status meetings that we held on Phoenix, I wasn't particularly happy with the meetings unless there was a handful of ahas that came up in the meeting. I didn't want anybody putting view graphs up and giving me daily status on 23 things. I wanted to know where the problems were. All right, so it's amazing when you get a group of people together and somebody's talking about an issue they're having, and then there's another subsystem that needs that component delivered or that analysis, and somebody goes, I didn't know you were having a problem with that. And so that it's all the communications and making sure that you don't have something percolating over here and growing into a bigger problem that you didn't know about. All right, verification and validation, another systems engineering theme. V&V is something that the projects tend to consider as being a mid to late life cycle task. You're coming up on you're in phase B, you're working on your PDR, and somebody says, oh, it says here one of the gate criteria is we need a verification plan. Well, if you're only putting your verification plan together because there's a matrix requirement that says you need a verification plan at PDR, you're in big trouble. By the time you get to PDR, as Martin well knows, because that's where Maven is heading right now, if you haven't thought through what are your requirements, how are you going to verify them, and then how are you going to validate the system, what are those opportunities that you have to figure out, are you building the right thing, not just can you prove that you're meeting the requirements, you're going to find a big steep hill to climb at the end of the program. The obvious things that people look at are verification events. All right, I've got requirements, I've got some component tests, subsystem, system test, but there's a whole category of validating your system and getting your team thinking early. And this really can't be overemphasized, that the ability of the team to think about off-nominal tests and mission scenario cases and get on that early really helps set the framework for where your risks are going to be. We've heard the last couple of days people talking about you can't test everything. All right, but you have to know early what it is you can't test. It gives you the opportunity to build a set of mitigations for how you're going to reduce the risk that you couldn't do that end-to-end test. All right, so there's a huge payoff. And so the message here is you need to avoid the trap of deferring V&V. Okay, requirements creep. We've talked about that one, and that's omnipresent. Engineers, if they're good, are trying to improve what you've assigned them to go deliver, and they want to make it as best they can with the resources you're allocating. So the challenge there is to make sure that they still feel empowered, they're inspired, they're enthusiastic, and they're doing all the right things with a damper. Right? And one of the challenges is, and this is again a systems engineering emphasis, if you understand your margins, you'll know when somebody brings you something that is true risk reduction as opposed to something that is masquerading as risk reduction is really just product improvement. So figuring out how you get those margins maximized in a relative sense and helps you figure that path out. And a lot of times, as you get deeper into the program, you'll get ideas that come up about off-nominal cases, and if you've had a failure, how do you respond to that failure? If you understand where the margins are, you'll have a much better idea on which ones you should accept and which ones to reject. Okay, of all the margins that you should strive for, my personal opinion is this one is at the top of the list. Power margins, right? Given a choice, I will buy watts early in the program because I'm going to need those watts later. All right, your engineering staff will do their level best to tell you what it's going to take, how much power you're going to need, and you know what? It's not going to be right. It's going to be wrong. You're going to find out that you needed more power for thermal, and you're going to find out that you've had temperature gradients that you hadn't counted on. You're going to have to put more heater power into keeping your alignments because of thermal distortions, and you're going to find out that when the fault protection team starts rooting around in here because you're going to another planet, you're going outside of Earth orbit, and you can't talk to this thing all the time. You're going to have 2 contacts a week or something like that. You've got to do the things that it needs to do autonomously, and the solutions to those can only be done with the software and the sequences, not with the hardware, because that's been committed and that's already integrated sitting on the clean room floor. And a lot of times power is the only way that you're going to solve that problem. Well, okay, I might have to go through a reset. I might have to do a sun search slew. Do I have the battery power? Can I recharge my batteries? And those things you don't learn until it's way too late to fix it with hardware. Okay, and the last item here, work to go audits. This is something we started on MRO, I believe, and Steve Jolly knows all about this. EVM, this is not meant to be an indictment of EVM, but EVM does not tell you all the things that you need to know, and EVM tells you a lot of things with a lot of detail that aren't particularly useful. When you get late into the program, everybody's been dutifully monitoring their progress, reporting their progress take-up, evaluating progress against budget and the actual expenditures, and that's all well and good, and everybody from outside the job is looking at your metrics, telling you if you're green or yellow or red, but you still don't know what it's going to take to get the job done. All right, so your cost cap, there's pressure to get the team rolled off. If you leave the staffing where it wants to be, it's going to stay pretty flat until launch, because everybody wants to be a part of the launch. They want to make sure that they're following what they've delivered. You can't have it. You got to push the staff down, get people off. But if you're too focused on that, you're going to miss the fact that the labor that you have allocated can't close the tasks that are remaining. So these work-to-go audits is something that about the time that you're ready to start environments, your leads ought to be able to figure out, okay, what are all the tasks that are still on my list? Yeah, I've got this earned value plan, but I need to know what's the full list of things that you have to do, and how much labor do you think it's going to take to finish each one? And it's kind of surprising the results you get from that. Right? You find out that your telecom system, for example, oh yeah, I've got all that stuff on my plan, but you know there's 18 other things that never made it onto my plan, and I hadn't really thought through the budget to get that done. And what that allows you to do, if you get on that before your system environments, it allows you to put the resources in so you get that stuff done and you get your verification done orderly, and that way, as you're trying to focus on launch and all the things that come out of the woodwork as you're getting closer to launch, you actually have an orderly verification. The risk that you run without doing something like this is that you get those surprises late where somebody still had 50 verifications to go, and you're wondering why they're at 48 and why they're at 45 and why they're not at single digits. All right, so this is a really good tool to help you manage, and again, the theme is stay in the box, figure out ahead of time where you need to be, use the anticipation of what the team needs to be doing 6 months from now, and this is a really good tool late in the game. So that's my summary of how I found it useful to try to stay within the box. So thank you.